What we're trying to do today is to generate issue or raise an issue and generate some awareness about drain management as a holistic system rather than looking at components. And like we saw yesterday, there were questions raised about what happens with reducing the flow rates. Is reducing flow rates adversely impacting our ability to dispose of waste and carry solids and so on? What I'd like to raise as a first point is that our conventional drain systems are traditionally inefficient. And when I say that, we've all accepted to live with secondary maintenance techniques, i.e. the drain system gets blocked or clogged and we pour chemicals, or we use secondary mechanical means, snakes, call a plumber, or open or disassemble the drain and try to fix it ourselves. And all of those have become kind of routine in our lives, and we basically accept those as the solutions. However, can we imagine that traditionally, even with 2.5, 3 gallons a minute flow rates, we've had these problems? How can we make a statement that we go from those to 1 gallon a minute flow rates, that there will be no problem or that there will be no increase in problem? So what we're trying to raise here is awareness and an issue that we think will cause a bigger problem in the future. We just don't have enough data point because the reducing of flow rates is a recent phenomenon. If you look at the traditional drain management, we all suffer from slow or blocked sinks. We all suffer from corrosive chemicals that hinder the performance of the system. If you look at the safety and environmental issues that we all deal with on a daily basis, there is contamination of gray water, which results in challenges to the water treatment facilities, which means you need more energy to treat water because you have more contamination. There is damage to plumbing and fixtures, which means there's cost associated with those. Potential kids and pets poisoning, potential burns to eyes and skin, inhalation injuries, and these are all established data. If you look at the National Safety Council, you have these data points that there's tens of thousands of people that get injured annually and get hurt with chemical cleaners. With mechanical cleaners, we get exposed to contaminants. When we disassemble a drain, the whole concept of drain or P-trap is that you don't have to disassemble and you don't have to ever have the sewer gases coming back in because you want the seal. But you disassemble, and for that 15 minutes to an hour to 2 hours, whatever it takes for you to go buy one and replace it or whatever, there is actually not a water seal in there, and therefore the whole property is getting contaminated with sewer gases. All of this is not cheap. When we look at a P-trap, the P-trap may cost only $3 or $4. But when we look at the total cost of ownership and maintenance, including the mechanical equipment that we buy, the chemicals that we buy on an annual basis, the plumbing services that we rely on, and our own time and frustration that we spend on these things, that it's very, very expensive for an average consumer. Yesterday we looked at direct linkage between energy and water. And there's about 8% of energy usage in the US directly linked to water in some form. So the focus is reduce the flow rate at the supply line, and that way we can conserve water. That's what we've all seen. Here is samples of low flow rate faucets and toilets, and that's the technology in there, which is great. We are able to get a direct linkage. However, when we look at in the context of the existing drain systems and the drain management, now that we have reduced the water, there is potential that we've caused another problem, and therefore we may be giving away some of the efficiencies that we will be gaining by reducing the flow rates in the process of increasing the use of chemicals, increasing the use of mechanical treatments, increasing the use of opening the traps, etc., etc. So that's a concern that we are trying to raise, that the system needs to be looked at in totality and not just at the supply line, but also at the disposal line and the waste management line. We've looked at the standards that have been developed by LEED, NAHB, EPA, WaterSense, and most of those standards focus on a lot of issues around environment and water conservation, but they have kind of left out the area of what happens when after you've reduced the flow rate and the water's come down the sink. what happens after that. And there is no standard provided for products to be developed around that area so we can improve the efficiency of the system. Here's a hypothesis that we are making. We're making a hypothesis that when you reduce flow rate, there is a negative impact to the efficiency of the system. And the reason is that in the system, the first component is a P-trap, which we all are aware of. But then you further down the line, the waste storm, the pop-up drain, and then further on, until you get to the main drain pipes, there are several portions of the components which become more inefficient in presence of lower flow rates than the higher flow rates. Traditionally, when you have a slower clogged sink, we pour more water, or we fill up the sink and try to clean it, or we pour chemicals. And all of that basically is giving away some of the advantages that we are getting from reducing the flow rates. So here's an experiment that we performed to prove the point that if you were operating at 2 gallons per minute, and this is the outlet coming from a waste arm going into the wall from a P-trap. If you're operating at 2 gallons per minute flow rate from your faucet, you can see the amount of water that's coming out in terms of its height and its width as a ratio of the line. When you go from 2 gallons per minute to 1.5 gallons per minute to 1 gallon per minute, that width and height goes down by about 1/3, which basically means what? Our belief is, based on this experiment, that if there was a debris that could have easily flown away in this kind of situation, it could get held back, which basically means that there is higher inefficiency introduced into the system, and our dependence on secondary maintenance techniques of using chemicals or using secondary maintenance goes up, which is again compromising the gains that we are getting on the water conservation side. So to prove this point, we did some more tests, and the first test was we poured a cup of carrot peels in a traditional 1.5 inch P-traps, in the sink system without going through the garbage disposal. And what we found is that not one carrot peel came out, even though the water was still flowing at a reduced flow rate, but there was still, all the carrot peels got stuck into the trap. And what that means is that they would stay there, and over time they would degrade and then become contaminated and then become a clog. We have no ways to see what's going on there. We have no ways to fix it unless we see the symptom on the surface when you have a lower flow rate in the sink. We also notice that if we put a new P-trap in a sink, and this is after 12 months, that just the traditional debris that's going through it, the toothpaste and hairs or whatever, forms a biofilm, and then there is contaminants built there, and you have bacterias and molds and mildews and all those kinds of things getting built up there. So in our opinion, there is a need for managing the total system, not just at the component level, but as a system level. We believe that if a holistic view is taken, then there will be improvement in impact to the environment, there will be better life of the structure, and it'll improve in the products that are installed into the building. There are different system attributes that can be addressed. Some of them can be just addressing the life of the components that we're using or the materials that we use. Some of them can be related to reducing blockages. Some of them can be related to improving inspection capabilities, self-maintenance, reduction in usage of chemicals, and so on. However, like I said before, there is no standards or guidelines available that encourage anybody to develop products around these areas.